In this video, we're going to talk about some basics of statistics and collecting data and different ways of doing that. So first of all, statistics is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. And when we talk about data are just observations. Things like measurements, genders, survey responses that describe characteristics of an individual. When we do polls, studies, and surveys and use other data collecting tools, we collect data from a small part of a larger group so that we can learn something about the larger group. This is a common and important goal of statistics. Learn about a large group by examining data from some of its members. Now let's talk a little bit about statistical thinking. Whether conducting statistical analysis of data that we have collected or analyzing a statistical analysis done by someone else, we should not rely on blind acceptance of mathematical calculation. We should consider these factors. First of all, the context of the data, also the source of the data, the sampling method, and conclusions. Also, practical implications. So let's talk about the context of the data. What that means is, what do the values represent? Where did the data come from? Why were they collected? An understanding of the context will directly affect the statistical procedure that we use. Next, the source of the data. Is the source objective? Is the source biased? Would there be any incentive for those collecting the data to distort or spin results to support some self-serving position? Is there something to gain or lose by distorting results? These are all very important things to consider. Be vigilant and skeptical of studies from sources that may be biased. Also, we want to look at the sampling method. Sample data must be collected in an appropriate way, such as through a process of random selection. We'll be talking about sampling methods and random selection a little bit later in this video. Does the method chosen greatly influence the validity of the conclusion? Voluntary response or self-selected samples often have bias because those with a special interest or a definite opinion are more likely to participate. These samples' results are not necessarily valid. Other methods are more likely to produce good results. And when we talk about a voluntary response sample, we mean something where the respondent chooses whether or not to respond. So something like a mail-in survey or something that you see on the internet where they ask you to respond to a survey. Conclusions. Make statements that are clear to those without an understanding of statistics and its terminology. Avoid making statements not justified by the statistical analysis. And practical implications. State the practical implications of the results. In other words, what can this be used for? What is it good for? There may exist some statistical significance, yet there may be no practical significance. Common sense might suggest that the finding does not make enough of a difference to justify its use or to be practical. When we talk about statistical significance, what we want to do is consider the likelihood of getting the results purely by chance. If the results could easily occur by chance, then they are not statistically significant. If the likelihood of getting the results by chance is very small, then the results are statistically significant. So the subject of statistics is largely about using sample data to make inferences or generalizations about an entire population. it is essential to know and understand the definitions that follow. First of all, the population. The population, in statistics, is the complete collection of all individuals, scores, people, measurements, and so on, to be studied. The collection is complete in the sense that it includes all of the individuals to be studied, the entire group that we are interested in. So first, when we talk about the population is the entire group of individuals to be studied. Now, our population could be a group of people. It could be all of the fish in a lake. So a population is just an entire group that we're interested in studying. Now, usually we don't have the time or the money to get the information about the entire population. So to save time and money, we choose a sample, which is a subset of that population. So we have a large group that's our population. Our sample is a smaller group that's representative of that population. Now, an individual is a person or object that's a member of the population we're studying. So again, an individual might be a person if we're studying a group of people, or it might be a fish if we're studying the fish in a lake. Now, we can also have what we call a census. A census is a collection of data from every member of a population. So in some cases, it is possible to get the information about the entire population. And in that case, instead of calling this a sample, we call it a census. A sample is a subcollection of the members selected from a population. So a sample is a smaller part of the larger group. Now, sometimes it's hard to tell the difference between a population and a sample. So here's some tips. In a poll or a survey, the sample is the set of all of those surveyed. The population is always a larger group than the sample. And if the sample is chosen from a group with specific characteristics, then the sample can only represent a population with those same characteristics. For example, if the sample is selected from U.S. citizens, then the population represented by the sample is only all U.S. citizens, not all people in the United States. Here's an example. A Nielsen television survey of 4,000 households in the United States finds that 2,988 of them watched the final episode of American Idol. So in this case, the sample is the 4,000 households that were surveyed. Notice it doesn't matter how many of them watched American Idol or not, the sample is everyone that was surveyed. The population represented by the survey is all households in the United States. Notice it doesn't represent all people in the United States since it was only the households that were surveyed. Also, it doesn't represent households in other countries since the sample was taken only from households in the United States. Another example. A newspaper article reports that the president's approval rating is 33%, according to a Gallup poll of 1,022 adults in the United States. The sample is the 1,022 adults surveyed. Again, we're not talking about how many answered yes that they approve of the president. We're talking about how many were surveyed. The population represented by the survey is all adults in the United States because that was the characteristic of those that were sampled. It doesn't represent all people in the United States because children were not included in the sample. Also, it does not represent adults in other countries since the sample only included adults in the United States. Now, a statistic is a numerical measurement describing some characteristic of a sample. So if we have a sample and we get some kind of numerical measurement, for example, an average or a percentage, then that average or percentage, is called a statistic. Notice that sample and statistic both start with S. A parameter, on the other hand, is a numerical measurement describing some characteristic of a population. So if we have a census where we have all the information for the entire population, and we take that census and get a numerical measurement from it, like an average or a percentage, then that number is a parameter. Notice that population and parameter both start with P. So an easy way to tell the difference between a parameter and a statistic is that if it comes from a sample, sample starts with S and statistic starts with S. So if it comes from a sample, then it's a statistic. If it comes from a population, because population and parameter both start with P, then it's a parameter. Here's one more example. Suppose the percentage of all students on your campus who have a job is 84.9%. The question is this a parameter or is this a statistic? Well, because it's talking about all the students on your campus, then we could assume that it's talking about the entire population. So that would make it a parameter. Now, suppose we obtain a sample of 30 students, and from this sample we find that 86.3% have a job. This time, because this is a numerical measurement coming from the sample, that makes it a statistic. So the 84.9% was a parameter because it represented all the students. The 86.3% is a statistic because it came from the sample of 30 students.